Okay, welcome to 3D path modeling. We'll have a whole series of videos about how to model certain garden elements, but in this video I'm really just focused on introducing some three-dimensional surface commands and how they apply and what's maybe the appropriate way to address the modeling of pathway. And there are multiple ways to do it, but there are some better ways, obviously, or more accurate ways to do it. So I've created a little bit of a sort of garden similar to what maybe you would have if I have some of these layers are actually off maybe as well. But what you can see is architecture, civil, landscape, existing layers. These are what you have in your base file. And when we start drafting our landscape proposed, we need to make sure that we put the landscape proposed in its own layer. And this is actually two-dimensional information. You can see down here I put L 3D landscape proposed is the 3D information. And so when you're drafting, it's really important that you keep your 2D line work, so your curves, polylines, all that kind of stuff. The 2D is all in its own layer family, and you know how I like to make my parent layers white so that I can see what I'm doing. And then here's the landscape proposed, and do the same thing with that one. And there are many layers in my particular file because I have all of these structures already completed, and they are sort of hidden right now away. But I'm going to be working with some of these guide layers for now, and a little bit of the 2D line work like site path. So organizing your layers super important for minimizing errors. I think also for just organization. And like I said, we need to keep 2D and 3D information separate so that we can easily turn things on and off. The other thing to remember is as we do this, there is a little bit of vocabulary. Any kind of line, things that you might call a line. In RHINO, we refer to them as curves, although obviously I'll be using line, polyline, curve, all interchangeably. But line work, vector work is curves in RHINO. And in the three-dimensional realm, we are making surfaces. This is the three-dimensional geometry that we will be creating in our files. So what I have is I want to eventually model the example that I have here in the garden, which will be at the end, where we'll use a combination of different modeling techniques that I'm going to explore with you here in these first 4 examples. Obviously, this is top view, and we will be working in 3D view, but we're going to use the top viewport. We're going to definitely use the front and or the right viewport. So what I have to do is make sure that when I select it, it's like, okay, I can see this geometry is here, and I know them in the right ballpark. So to begin with, the first command I want to actually explore, and you can see some of these commands that are written here on the screen. I want to explore what's called planar surface. So planar surf, you can type it in and it'll just come up, for you. The other place I want to locate or show you is in this menu with the four corner points. This is actually the surface creation menu. And so the first one is surface on 3 or 4 corner points, which we'll explore in a minute. And then surface from planar curves is the second one. And there are a bunch of different commands, and we'll be exploring, at least with the path, we'll explore a few of these in this video. But starting with planar curves, surface from planar curves. So to get a surface from planar curves, the first thing you have to do is have planar curves, which means that these are all, in this case, this is all, every curve corner and everything is at the 0 datum. So if I hit enter, it'll just give me a flat planar surface. For the three-dimensional world, it's not super helpful to have planar surface, but you'll see, sometimes in drawing sections and other things, it's really handy to be able to do planar surface, but most of what we do is not really planar, right? The landscape just really isn't planar. It's curving and changing all the time. So it's less useful, but I want you to see that as a particular use, as a command that's available to you. The next command, again, that we'll revisit when we look at creating stairs or concrete walls, is the extrude curve command. So let's again just pretend for a second that we had a flat walk, which I should remind most of you that is never the case. Nothing is ever flat. But in a quick sketch or whatever, maybe you need just a quick extrusion to be able to see something. It is something that we use a lot, but I would caution you to think about things as always being extrusions. That's a bad habit to get into. So let's do the extrude curve. Is actually on my key commands is just EC, because you can obviously see I use extrude curve for a lot of different reasons. In this case, let's pretend like this is a concrete pathway. So I'm going to extrude this curve, and I'm going to hit enter, and I can pull this wherever I want it to go. But I want to introduce you to a couple of different things within the extrude command. And we have an output of a surface. The other choice, or some other, it's a sub D. I'm going to go ahead and just tell it to do surface. Direction, if I wanted to change it down or up. Both sides, this is see, it goes both directions as I push and pull. It's going down and up, but I don't want that. Solid is, I'll show you, let me just choose it real quick and I'll show you what happens. Solid no means it just leaves a cap at the top. It leaves an opening at the top, and if you wanted to ever close that, you would have to press cap, the command cap, and it just caps it. Okay, so that's if you forget to accidentally make it solid, which happens all the time, just cap it. So I'm going to erase that, and we're going to type in EC again, and we'll go back to where we were. I'm going to make this a solid because I'm pretending like this is like a 4-inch piece of concrete or whatever, or maybe we'll just do 6 inches for now. Delete input. I don't want to delete input, and some other choices here that aren't used very often. So my units, and something to remember, the units here are feet. So if I want to go 6 inches, either I have to type 6 with an inch on it, or I just go 0.5. So 0.5 feet will give me a 1/2 inch or a 6-inch concrete pathway that's flat. I mean, this is something that is really, really, really basic modeling, and if you really, really love extrusions, I might invite you to use a program called SketchUp, because that's for you. The next thing we want to do is we're actually going to move this thing into 3D, not this just extrusion stuff. And in order to do that, again, these are a little bit sort of primitive methods, but they do work, and it's important that you see how they work. For a architectural or angled pathway where there's no curves, these could be some nice options. So what we're going to do right now is pretend like in the garden, this is the house and this is the gate. So the door to the house and the gate. And if you take a really close look at your house, you'll see that it's actually, the door is actually 18 inches above the gate. And so we're actually going to have to slope up somehow if we're going to do this path, or get this path up to the gate, from the gate to the door. So what I know then is with my, I'm going to use this as my guide layer. What I know then is that this point right here will be 18 inches. And notice I use the 3D to get the place that I want. Use the O snap, and then I'm going to type in 1.5 and hit enter. And what it's asking me to do is say, which direction do you want to go? And I can go all over the map here and be like, what am I doing? Why am I doing this? But what I actually want to do is go directly straight up, which is why I have my cursor down in the right viewport. And I'm going to temporarily engage ortho. So I'm going to hold shift down and notice that now when I move it, it either goes 90 degrees flat or straight up and down. Otherwise, it's doing all of this stuff. So hold ortho and then left click, and then you can space bar enter, and you now have a line that's 18 inches. So let me go ahead and quickly just check that. That's always a good idea. I had distance, and I'm going to check it. So it's actually 1.5 feet. So I did good. So what I'll do is, usually we're building off the center line, but because I'm doing surface from four corner points, I actually want to go ahead and just move and copy these to the corner points. So what I know is these two corners will be 0. This will be 1.5. What I'm going to do, just to show you how it's done, is I'm going to make these two corners, or this, when we hit this corner, this is 6 inches, this is 1 foot. So it'll just sort of move uniformly up to the 18-inch height. So I'm going to use polyline again. Pick a point here, come down to the right, I just type in 1 first, and then hold ortho, left click, enter. And then I'm going to copy that from the endpoint to the endpoint. Do this one more time for 6 inches, 0.5, enter, and then ortho, left click, copy. Okay, so this is these are my little guidelines. So oftentimes in 3D modeling, you're going to use some guidelines to give you some place to snap to. You're not going to be able to just freestyle click a button in the perspective somewhere in space and think you're going to get it right. So you always need to have some kind of guidelines or curves in order to create the surface geometry. So surface from 4 corner points is this one here, and if you just type SRF, it'll give you the surface points. So first corner, I'll just start at the top and work my way down, and I'm just doing the endpoint of all of these, and it creates a surface there. Same thing here. Same thing here, going down to the 0 and back up. And so what I have here is three different surfaces that make up this path. And what I'll do is just join those together. And now those are all, that's your path. Good job, you did it, all right? Let me go ahead and move this for a moment out of the way. And I moved it, it's still at 0. I moved it on the 0. What we're going to do next is the edge surface. And so this is surface from 2, 3, or 4 edge curves. So that means it's like the outline of the surface. So what I'll do is I need some edge curves to do this. Because this is a architectonic angular plane or angular path with no curves, it's easy to just use polyline, and I'm just going to go ahead and reproduce what we're doing here. And then at the end, I know that these are all connected. I'm just going to hit C, which closes them. And so that's all, that's the edge of the entire surface that I want to create. Now, there is no magically create an edge from one closed surface. Doesn't really work that way. So what we need is either 2, 3, or 4. So this is how we can do this, and this is very useful for a lot of things. And you'll see later how we use edge surface, especially for curving pathways where you need to use a curve or the edge of an existing surface as one of your surface edges. But we'll see that later. So what I'm going to do, just do a quick polyline. Doesn't matter. As long as it connects to the corner points, it works. And what I'm going to do here is split. So select objects to split. I'm going to split this into basically 4 edges. So four curves. So this is what I want to split. Enter. These are my cutting objects. So this is going to cut this closed curve here, 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 and here. So enter, and what that does is it gives me one edge, 2 edge, 3 edges, and 4 edges. So now I don't need these lines anymore. And edge surface is actually here, surface from 2, 3, or 4 edge curves, or you can just type edge, and that will get you the command that you're looking for. And I'm guessing that what we have here is exactly the same as this. It shouldn't be any different. The only difference is that you don't have to join these together. It's already its own surface. So I'm going to go, let's see, I'm going to move this to a different layer for now. So the blue ones are kind of done, and the pink ones will be what we're working on. So for the next path, we're actually going to do the same operation using the edge surface, but it's going to be using a curve with a curved path. It's really hard, you know, if you saw how I drew these polylines in three dimensions. It's a lot easier when you're using polyline. Once you start using these curves, it becomes a real challenge, especially to get it positively accurate. One way that sort of works, it's not to me the ideal way to do this again, but there's some utility for you to think about how do you rotate in 3 dimensions. So I'm just going to go ahead and do a polyline, and we're going to put a polyline at the end of this, 1.5, enter, and that gives us my 18 inches. I'm going to go ahead and do this for some reason. I don't know why I'm doing that, but it gives me an idea about where I'm working. Let me go ahead and hide. I'm going to hide all of this, primarily so I don't snap to it. And rotating in 3 dimensions, any kind of rotation that's not in 2D is a little bit of a challenge sometimes, particularly when we're looking at this right or front angle where we're not able to exactly snap where we want to. So we're going to give this a try and see what happens. I'm going to go ahead and rotate, and the object I want to rotate is that whole path. Now again, this is presuming that the path is going to be uniform all the way through. Otherwise this doesn't work. If it goes up a little bit and flattens off and then goes back down, you can't do this operation, which is why I'm saying it has some limited utility, but occasionally this is something that would work for some other thing rather than a path, like a patio or something like that. So I'll start with select rotate. Okay, good. I want to make sure I copy this because I want to keep my 2D line work in place. The 3D rotation is kind of interesting. I want to rotate it from here. I want to rotate it from this point up to that point. Well, when you select in 3D, you see what it's doing. It's just putting a flat surface down. And if I chose it, I'll go ahead and do this real quick. See, it's only just going to rotate this way. It doesn't want to operate vertically. We can use the command rotate 3D, but it feels very, it's kind of difficult sometimes to operate that command. So let's start simply. Rotate, yes. Choose this midpoint. And what I'm going to do is, you notice how all of a sudden the rotation goes vertical now when I'm in either one of these places. This one looks more like it wants to go this direction. I want it to rotate this direction. So the challenge is going to be, like, it wants to snap. It never wants to snap to the middle. Well, it only wants to snap to the end. Well, what I'll do is turn off all of my O snaps except for the mid. And then I can come in here, and actually it really does want to go to the mid. You just have to make sure you're at the right spot, which I got. Now I want to go to the end, so I'm going to select this end point, and now you can see how it's actually rotating upwards. And I'll go ahead and enter. So I copied that up. This is 2D geometry, so I want to move that to my guides layer. Don't need this line. I don't even know if I ever need that line. I just like having it there for visual purposes. And so what we have is basically we have the outline, and now we can just go in and do the same thing. By the way, you don't have to connect all this together, but it just feels like it's quicker that way. I'm going to go use split again, split this, enter. Here's my cutting edges, enter, and now get rid of those. And now I'm just going to type in edge. So it's pretty fast doing all of these, and that gives me my kind of quick and dirty edge surface, and my path should be flowing pretty good there. Again, I do think there's something this works for this problem. There are other ways that I think are better, especially for more advanced pathway systems, and so that's what we're going to do now. And here we'll use the command sweep to rails, and then we'll also take a look at the contour command, which for the sweeps is important that you see what's actually happening with the contour command. It'll actually show you what the path is doing a little bit better than just your eyeballs being able to see it. So sweep is really the way I think everybody wants to think about pathways being created. And so what we'll do is, again, we'll go back to that old 1.5 move. And I'm going to start simple here, where we will just go just exactly like this edge surface. We'll just go from 0 straight through to 18 inches. What sweep does is it takes some kind of geometry, and in this case we're going to just sweep this particular geometry, so just a flat line, and we're going to sweep it along the curve, or we're going to sweep it along these rails. So kind of like a railroad track. You got sweep to, it's like this is the train and it sweeps along to the end of the track, and it meets this one. Sweep one will actually use the center line. It's like a monorail. So I'll tell you in advance, sweep two for pathways for some reason just does not like create accurate pathways. And so, but I want you to see how it works, because sweep two is often the thing you almost have to use for certain things. But for pathways, it's got really some really wonky geometry. So let's start with go ahead and let's run the sweep so you can see what happens. As it says, sweep two rails. Well, we need two rails, and we have one geometry that's closed, and we have this center line geometry. So for this particular problem, I'm going to go ahead and offset, and I'm going to offset 2.5 because the path is 5 feet. And so I have my rails here. Just be careful when we select this that we don't accidentally select the 2D geometry that's closed. But type sweep and 2, and what it wants are select the first rail. So here's my first rail, here's my second rail, and it automatically, it's not looking for another rail. It already knows one rail, two rails. Now it wants to know the sweep shapes. So I want to sweep this along these rails up to this point. So even though these are 2D, it knows to go up to that point. So I'm going to go ahead and enter. And a couple things that are worth mentioning is the problem for some reason with sweep 2 is you can almost kind of see how this comes out pretty flat, and then it starts to bow up a little bit, and then it's a little bit flatter again. This is a parabolic curve, and most of our paths are going to be generally uniform. Let's say I just was going from 0 to 18. Well, we're not going to make it flat, 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 steep, flat, flat, flat. At least not the way I'm telling us to do this. If I'm saying go 0 to 18, I want this to be a uniform slope all the way through. We're going to do an example where maybe I do want it to go up and then be flat and then go up again. But I want to control that. I don't want the computer to do that accidentally or automatically. To contain this a little bit, and you'll see a little change happen with this surface, I'm going to go ahead and click the box, maintain height. So did that move at all? It moved a little bit. So it actually is trying to kind of flatten some of this out, but it's still really, really flat here, and it's steeper in the middle. And this is just part of the way sweep 2 rails kind of works for paths, and this is why it doesn't work. But let's go ahead and hit OK. The next thing I want to do is I'm going to change to this guides 8 layer, and I want to use, you can really see how that goes really quickly vertical here. Well, it's kind of flat here. But if you know anything about contours, which you'll learn at some point, that these contours should be even, so the spaces between them should be the same distance. So what I'm going to do is Contour command is just type contour. Sorry, I'll do this one more time. Type contour, select the object I want to run contours on, enter. I'm going to go ahead and I just need a base point. I'm just going to choose this 0 point, and then it asks direction perpendicular to contour plane. So I want to run what we'd associate with like a plan view or topographic map. So I want them to be vertical for this one. And then I went ahead, this is only 18 inches. If I did a 1 foot contour, I only get one line. It's not going to show me anything. So I did 0.25. I'm not keeping this for any reason other than just to assess, are they even or are they not even? And so quarter inch contours will give me a few contours on here. They're in yellow right now, but if I click off of them, you can see them in white. And so it's just exactly what I suspected from my visual observation, is that the path goes out very flat. You have this parabolic curve ascending in the middle, and then it's flat here. If you wanted to do this as a design move, you can. But I think the point is we need to be controlling this, not letting the computer just choose this not correctly graded pathway on our own. We intended it to be uniform. So just to give you a little bit of a contrast, let's see what happens when I do contour on this surface. So same thing, vertical, and I'm going to hit enter, and you can actually see this is actually kind of not really correct the way we rotated it, but you can see that they're at least they're the same distance apart, right? They're uniform, even though they should be perpendicular with the edges. So we'll see how that works out in the next round. These are still not perpendicular either, but let's see what happens. So we're gonna probably do 2 versions of this. So sweep one rail, same idea. We're gonna do polyline. Go back to my layer, 1.5, enter. Need our, what I'm gonna do. I need my same geometry that I had before. Copy this, midpoint to midpoint. So S1, the center. It's already ready for me to choose the sweep shapes. So we'll do this one again, all the way to here. Hit enter, and one of the things we want to do, you'll see, just like maintain height, if I click global shape bending, it's going to, you can see that thing flattening out, and that's actually much more accurate for what we want to see. I'm going to just unclick this for fun to see it. Look at it, actually is sort of putting that weird geometry back in there. So refitting the rails is usually an important thing to do with the sweep 1 pathway system, global shape bending, refit rails. Hit OK. And now let's test this with the contour command. Select what I want to run contours on, go back to my 0, 0, go vertical here, change my layer real quick, and contours 0.25, we'll do that, and enter. Now, what you see here is, remember, because we rotated it, we sort of rotated it not, we rotated it off this kind of strange axis, and it ends up not being perpendicular to the edges. Sweep 2, something also to do with these outside edges. It's a parabolic curve, and they're not perpendicular to the edge of the pathway, which is not correct. Sweep 1, using the center line, they are uniform and they are perpendicular to the edge. So thank goodness we got this correct in grading class. You don't fail. They may actually be slightly off with their distance in places, like it may not be perfect, but it is close enough to be like, okay, this is where it sort of needs to be. You may, if you're getting really, really accurate, you may have to like measure some of these and maybe move this one just a little bit. But I think that's a level that we're not even looking at. We're we're here, we have a correct path, and we're moving on. We can model other things. But sweep 1 is the way that we want to operate on these type of paths. And you could even do it on the first one that I showed too. Copy this. And then let's go ahead and get rid of some of these things that we don't need. So now I want to look at an example where we actually have the path slope to this straight section, and then it maintains a gentle slope along the straight section, and then it continues to slope upward to the 1.8, 1.5, 18 inches. So a lot of times you'll have a path that changes slopes along the way. It's not always uniform. Instead of thinking about building the path all at once, we may have to take it in sections. And so we'll only construct one piece of it at a time. So what we'll do here is I've done a little bit of preliminary work while I understand how steep I can go here before it gets a little bit strange. What I'm thinking is that we go from 0 to 0.8 at this straight section. We go from 0.8 up to 1.1, and then we go 1.1 to 1.5. And that will give us a pretty good path, and it gives you an example of how to do this operation. So polyline, and then I'm going to choose this endpoint, so it's the beginning, the end of the curve, beginning of the tangent. So we'll go 0.8, enter, just like we did before. Do polyline again. 1. Oops, sorry, I said I was going to do this 1.1. Let's do this again. 1.1, enter. And now we have defined those heights. We'll copy this curve because it doesn't know, it doesn't know to go vertical here unless I give it its the cross section or the sweep shape. So I have to do that here as well, but this is at the wrong angle. So what I need to do, and this is easy to do without making this guideline, but I just want you to see, is that I want it to be, it's easier to see this, I want it to be, make sure I'm perpendicular to this pathway. So as it makes the curve, the cross section is also operating at that same angle or perpendicular. So now I'm going to rotate. So I just copied that vertical line, and I'm using it as a guideline to get this sweep shape into perpendicular. Copy. This is the same. It's the same geometry. I don't need to rotate that because it's along that straight section, and so it'll bend around that corner, bend around this corner. I don't believe that this will work very well as a singular sweep, but let's try it and see what happens. My guess is that I need to actually sweep at least this section because it's kind of steep. We're going from 0 to 0.8, and here we're only going from 1.1 to 1.5 along this about, 20 something feet. Here's just a touch under 20 feet, and trying to do it too steep is going to cause, the computer has to be able to the sweep has to get from here up to here and then go flat and then adjust, and that can throw off the geometry a lot. So sometimes it's easier just to do them as separate surfaces, but we'll try it as one and maybe it'll work. I'll do both regardless. So sweep 1, gonna do center line, and then here's my sweep shape. So I'm just doing the whole thing. Let's see what happens. It doesn't look too bad. Oh, it's bulging right there, pretty good. Just do global shape bending, and it really gets off. So I can already see, this is totally wrong up here, how it bows back down. It should be just uniformly up. And so I have to have global shape bending on for it to actually be accurate. And you can kind of see this is, I'm just going to accept it for now. I know this isn't going to work, but I'm going to accept this. And then what I'll do is I'll copy this over here and erase it. And I am really concerned that that's not correct. So that's why I wanted to copy it and then I'll hit contour, and then see what happens. And yeah, you can see this parabola happening here. Like this distance is more than this is, and then this is farther away. And again, at least until we get to this part of the surface, it needs to be even. So it's doing this parabola, and I knew that this was going to be a little bit of an issue. I know this is like a really detailed fine point, but I need you to be able to see this. And so we'll leave that. I know that's not really correct. And so if it gets a little bit wonky when you have global shape bending on, that's when you know you need to cut it into two parts. This isn't going to be bad though. I think sweep 1. I'm going to do the same rail, and I'm going to sweep from here to here. I'm just going to do this only. And go back to my layer here, and I need global shape bending. And notice the difference. It's actually, because it doesn't have to convert to this flat area, it can actually just make that uniform. It's not a hard geometry for it to do. So global shape bending is keeping you out of that parabolic language, and more into a straight uniform geometry. So I'm going to accept this, enter. And now there's two ways to do this. I could just sweep this all the way through. I've actually done this ahead of time to see what would happen, and sweeping this all the way through is exactly the same as about what I'm about to show you. But if you ever get in a situation where, let's pretend like this is kind of steep, this is pretty flat, and this is steep again, well, this middle section, maybe you could sweep it separately, or you can just give it the old 4 points surface, and as long as these two align and are precisely together, you can join them. You know you've done it correctly. If for some reason it doesn't work, you've got to go ahead and use the sweep instead of this 4 points surface. And then to finish it, sweep 1 again, and I'll use this one. And for my sweep shape, it's asking me here, do I want the curve or the poly surface edge? And if you have the option, and you know, if you have the option, make sure you use the poly surface edge. So if this previous surface doesn't join, then you go back and you use the poly surface edge. Anytime you're trying to connect two surfaces together, occasionally, and actually quite frequently, the surface will deflect away from the curve that you were actually had as an input, and so you need to make sure you always use the surface edge if you can. I don't think there's any difference between these two, but I just want to highlight that it's giving us an option, so use the surface. Got that one, and then I got this one, and I hit enter, and again, let's take a look at what this one does. Right, we like our global shape bending on here, so I'll hit enter, and then again join the two together, and all of that is should be good. And like I said, I swept it earlier from here all the way through, and I got exactly the same contours, just as a test to see. And then let's do contour. Let's test this out with the contour. Now we are changing, again, this is not a uniform slope, so all of these should not be the same distance, except for the ones that are between here and here. That's the same slope. This is the same slope, so we don't have enough to actually see that happening. But here we can tell these are pretty close to the same. If you ever were like, hang on, I really need to see this, we'll just tighten up your contours. So contour, and instead of doing 0.25, I'll just do 0.1. So we just throw a bunch of these in here, and then you can start to see that this slope is fairly uniform. It may not be spot on. It looks like it's getting a little parabolic as it ascends here. And then these are, I'm sure they're exactly the same distance apart. And again, we're starting to see that here, that they're either right on or they're very, very close. So that's the kind of contour check that I use to make sure I'm doing it correctly. So let me go ahead and I get to copy this back again into that position. So we got that going. And if you ever have that situation, just take the path apart and do it in different sections to make sure that you're getting an accurate reading from your modeling. So many of you will probably have situations that require using different some of the different commands that we've learned. Also, if you look at my kind of design, I have this is your path that moves along the middle of the garden, and then we have these like side pathways that connect in with other geometry that's on the site. In this case, these are like little stairs to a pavilion that's disappeared for now. But if you have this situation, it's very hard to try to just model the entire thing as one piece and do it sort of accurately. So what I'm going to give you here is an example of how we might do this in pieces. I'm going to go ahead and just say that this is my design, the one that is not uniform slope, so it ascends fairly steeply, and then flattens out at the top. This is kind of a problem though for this design, but we'll deal with it. We're not in grading class right now, but I'm just trying to create a little bit of complications for you to see how this works. I'm just going to copy this surface for now, and I think that's all I need from that geometry. What I'm suggesting here is that you actually do the same work with the geometry that you did here to get that surface, and then we'll create these surfaces on the side based on this geometry that we have in the sweep. So once you've got that center line set up, let's look at what we can do. We need to actually figure out how to get this geometry in, and we want it to be to touch exactly this edge surface. So for a second here, I just need to do a little quick measurement. So I'm going to hit DI, so that's distance, and I want to go perpendicular. So that's 1.37 feet. This is DI 1.32 feet. So it is sloping up a little bit. It's not much. And then let's just say for fun, that's 1.37. This is 1.2. Let's say this is at 1.5. So that means I'm just gonna. So it's the same as height as the house. So I'll go 1.5. Enter. So I'm just setting this up at having a height. You could do it 1.4. You can make it generally flat for this project, but again, I kind of want to show you how this works. So this particular piece is actually it's not on a curve. So we know that this is this geometry is a straight geometry. So it's actually really easy to make a surface because it's really just making a rectangle. So in this case, I know my heights here. I know that I want my heights to match up over here. So I'm going to go ahead. I don't have to do this, but I like to have just going from the corner up to the perpendicular. So these are actually my 4 corners that I can select. And I'm really trying to avoid accidentally snapping onto these stones, but we're going to include the stones in at the end of this once we get our path going. So what am I talking about here that you can actually see and make sure that if you see any daylight in there, it doesn't match up. Sometimes it doesn't, even if you can't see daylight. But here's what we have to do to check it. We need to, if you join it and it joins, you're good. It's a watertight surface. You don't have to worry about doing anything else. If it doesn't join, you'll have to use the edge surface command, which is what I'm going to show you how to do next. So if that ever happens, this is what we need to do. And now, remember I had said that on a curve, I'm not going to be able to do 4 points, because if I did, I'll show you what happens. And let's look at this distance. We'll go through that same process, 0.4, 0.6. So I'm just going to go, I'm going to say this is, I don't know, maybe this needs to be uphill, but I'm just going to say it's downhill for now. So I'm just going to go 0.5, so somewhere in between. And then I'm going to copy this. So this is the same on this end. I'm making just really easy geometries at this point. So remember, surface from 3 or 4 corner points, it is just not going to work, right? Because I've got a gap right here. It won't join. So this is where it gets a little bit tricky, but I also can teach you some new and very handy commands. So remember, I'm going to use edge surface. So I'm just going to go ahead and make my edges. Okay, this is 1, 2, 3, and I need to use the edge of this surface. It's really hard to try to draw and reproduce this manually, but there is a great command called dupe, which is duplicate edge. So you can dupe border, gives you the entire border of the whole thing. Why don't I do that real quick just to show you. Dupe border. And I'm going to duplicate the border of that surface, and look, it gives me the entire border. I don't need that. Dupe edge. I just need the edge of this surface, and notice it didn't even do the whole thing. It just gave me this one. So I duplicate the edge. It converts it into a curve. And by the way, technically speaking, if we're doing this correctly, we are putting this on a different layer, so they're not the same layer. So you can really see what you're doing a little bit better. Now, I only need the edge between these 2 curves. I don't need the rest of it. So this is the where the old trim command comes in handy. So I'm just going to trim, use those 2 as my cutting edges, and trim that out. It may be hard to see. We turn off the surface for a second, and you can see we have that edge, and it precisely corresponds to the edge of the surface. And now I can just type in edge and select these 4, and that gives me that. And if I join it together, it should join perfectly, and we have, it's actually not too bad. We now have a completely joined surface, and we are creating a path with stones in it, right? So what we're going to do is actually another very useful command is I'm going to type project, and it's just project, so it's really just project some objects to a surface. So project, so it selects curves and points to project. So I'm going to project all of these, and you can do it this way if you're really careful and not to select any other geometry. So I'm going to hit enter, and it's going to ask me what surface do I want to project these things to. And the surface I want to project them to is this surface. So I'll hit enter, and actually before we do that, delete input, no, because I'm saying don't delete the stuff that I'm already using. Don't delete my 2D geometry. Basically, output layer is current, so yes, I want it to go to this current layer. And then direction is the plane Z, so it's going straight up in the Z axis. So hit enter, and what it basically did is just pushed all of that geometry up against this surface. And before we do anything, I think we can get our next operation in is to type split. I may be wrong here. Split. Oh yeah, sorry, didn't work. I wish split worked the other way, but it doesn't. So it wants to do, I want to select the cutting objects second there, or first there, but it wants to do the surface or the thing you want to split, and then the cutting objects, which you'll see in a second here. So I don't need these old path stones anymore, and I want to be really careful not to mess with anything underneath. So let's do split again, and we'll have to select all this geometry again. I want that to be the object that I split, and it wants all the cutting objects. So this is where you got to be kind of careful and go through and make sure that you are selecting these and nothing else. And in some cases, having it on ghosted has the potential to select something that's beyond that surface. If I turn shaded on, it's not going to be able to choose something under the surface. So there are different times when you need shaded and ghosted on. And this is one that you need shaded. So I could use a window. I was a little bit worried about selecting something accidentally, but I think it's okay. And then I'll go ahead and hit enter. And what it's done is it's split this surface where I have this surface. So if I just delete it just to show you, and I have the surfaces in the middle. So I'm going to make a new layer L, and I'm just going to call it 3D stones. And I'll take every one of these, and it's probably a good idea not to try to choose all of them all at once. Just 3D stones, 3D stones. Oopsie, things can get weird. And then just do these one at a time, or not one at a time, but small batches at a time. And I'm holding shift down to select all of these. If you're brave, just do them all at once. And the point of doing this is that, you know, when you go to render, you're going to need the path on, you're going to assign materials. And so the pathway is going to be the material that's, say, gravel. And so that'll have a material assigned to it. The 3D stone is going to be stone. So that'll have a material assigned to it. And you need those to be on different layers. We'll deal with the assignment of materials later, but this gives you a kind of understanding of how to construct that. If you render it right now, it's just the same thing. But once we assign materials, you'll see the difference that Lumion will be able to assign them, you know, gravel to gravel and stone to stone. And you need to be able to control that, and you do that through the layers. I hope this was helpful.